So right here, we are going to decide whether the data set could represent a quadratic equation or not. And in order to do that, you need to find the first differences and then move on to the second differences. So let me zoom in and let's find our first differences. So on number one, what I would do is write down first differences or first diff. And the way to do that would be to take 22, take away 35. And 22 take away 35 is 13. Okay, so notice I'm writing the negative 13 in between the 22 and the 35, right in the middle. So again, 22 take away 35 gives you negative 13. Let's move on to the next one. 11 take away 22. What's 11 take away 22? Negative 11. And for the next one, what's 2 take away 11? Negative 9. And for the next one, we have 5. Negative 5 take away 2, and that'll give you negative 7. Ladies and gentlemen, those are, bless you, our first differences, right? So now let's go for our second differences. Second D, whatever, doesn't really matter. So how do we do the second differences? You go negative 11, take away a negative 13. Now take away a negative 13, that's really a plus 13. So what do we end up with? 2. Whoa. 2. Right? Negative 11, take away a negative 13. If you do that on a calculator, it'll give you 2. Negative 9 minus a negative 11, that's also 2. Negative 7 minus a negative 9, that's also 2. And that's about it, guys. The second differences are common, so you could say, yes, it's a quadratic. But you know what? There's something very, very important you need to do even before saying, yes, it's a quadratic. You need to make sure that the input values, the x values, that they're equally spaced. So just make sure that they're equally spaced. Negative 1 to 0, 1, 2, 3. So yes, they're equally spaced. So we could definitely say that yes, this represents a quadratic. Okay. Once again, if your first differences happen to be common, then you don't have to do the second differences. If your first differences are common, it's a linear equation. But if your first differences are not common, you got to check your second differences and make sure that they are common. And if they are common, then yes, it's a quadratic. If this would be a 2, a 3, and a 5, then this would not be a quadratic. You would just say it's not a quadratic. I hope that makes sense. I guess to write your final best answer is yes, it's a quadratic because your second differences are constant for your equally spaced x values. So there's your final answer. Yes, it's quadratic because your second differences are constant for your equally spaced x values. Moving on to number 2. So let's find our first differences, and once again I'm going to write first D. Okay, so we're going to go 10 take away 8, or 10 take away 18, we get a negative 8. 6 take away 10, we get a negative 4. 2 take away 6, negative 4, and 1 take away 2 is negative 1. Now let's go for our second differences. Second D. Okay, so if we go negative 4, take away a negative 8, that's going to be a positive 4. If we go negative 4, take away a negative 4, that's really a negative 4 plus 4, that's a 0. And if we go negative 1 minus a negative 4, that's really going to be a 3. So obviously your second differences are not common. So what do we say? We say that it's not a quadratic. It's not representing a quadratic function. So you say no, not a quadratic. So we would say that it's not a quadratic because the second differences are not common.